Hello Leetcode, so what's up? So today we are going to solve day 13 problem in the Leetcode main challenge. So I could not upload this video because I was too busy yesterday. So I was trying to cover the yesterday's work today. So let's get started. Uh, Given a non-negative integers, okay, non-negative integer num represented by a string. Remove k digit from the number so that the new number is smallest possible. Okay, so we are given a number and we'll have to remove the k digits to make it smallest possible. Okay, the length of the number is less than this and will be greater than equal to k. Okay, uh, the given number does not contain any leading zeros. Okay, cool. So let's just inspect some of these examples to understand the problem better. So we have we have this problem. We have this example where 1 4 3 2 2 1 and k equal to 3. So basically we need to remove 3 elements from this string to make it smaller. So we will first remove 2, then we will remove 3. 2 and 2 are equal, so the number will become 12219 now, and we still have one digit to remove. So if we remove 2, one of the two, it will become the smallest because 1219 is smallest. Okay, and let's take this example. So k equal to 1, we can only remove one string, only one character. So to remove one character we will actually start from left. If we will remove 1, it will become 0. It will become 0 to 0 0. If I remove 0, it will become 200, which is smallest possible. uh, k equal to 2 and the length of the string is also equal to 2. So in that case I'll have to remove both of these characters. If I remove both of these characters, there will be an empty string that will be left, so the output will become 0. Cool. So the basic approach or the way that it can be solved is we, we can loop through the string, given string, and whenever the number is smaller than the previously large number, we can remove that previously large number we have seen. So in this case, let's say we start with 1, so we have not seen any number, right? Now we come across at 4, so now we have seen 1, but 4 is larger than 1. So if the given number is larger than the number that we have seen, we can just append it, because it could be like one of the smallest, right? We will only remove if we get something that is smallest than whatever we have seen, right? So for these kind of applications, I think stack will be the best use case, because it actually keep a track of the of the element, and you can basically append and pop from a stack in a constant time. So we will be using stack here to basically input all the elements that are larger than the stack top, and if the element is smaller than the stack top, then we will remove all the element from stack top which are larger. So let's just take this. So let's say I have a stack and my stack is like this, right? So I'm looping through this string, which is this string, right? So if I'm looping through this string, I basically start from 0. So my stack is now empty. If my stack is empty, I just append that character onto my stack. Now I have 4, so this will become here. So I commit 4, so 4, and the top of the stack is 1. 4 is larger than 1, so we will just append it onto the stack. Right now we come across at 3. Now 3, and the stack top is 4. So top of the stack is 4, which is larger than 3. So since we now have a smaller element than we have seen previously, we can just remove this element from the stack, and we can use 3 instead of this. Right now we come at 2. So if we come at 2, we will basically, now again the stack top is 3, so top equal to 3, and I have current element as 2. So 3 is larger than 2, I can use 2 instead of 3. And yes, by the way, whenever we are popping from the stack, we are also keeping note of that how many element we have used. So our k will keep reducing. So when we pop 4 from the stack, we know that we have used 1 element, or we have removed 1 element, right? So our k now left is 1, right? So when my 2 will come, actually k is 3 here, I guess this k is 3 here. So the k will become 2 after I remove 4, and now if I remove 3, k will become 1. So and my 2 will come here. So now I keep going because this is smaller, so I keep appending onto the stack. Now again I basically got the element which is smaller than the stack top. Stack top is now 2, and my current element is 1. So and I still have my 1 digit left to remove. So I can simply remove this. I can append the current element here, and my k will become 0 now. Right now my loop will come to 9, and it will append 9. So now whatever is the value at inside the stack, that will be the smallest possible number. So let's just take one example for better clarity, and then we will move on to writing the code of this. Right, so here k is equal to 1, right? So basically in this case I'll start from 0th position, and then from 0th position my stack will be, so this is my stack will be empty first. So if my stack is empty, I will simply input my first element, move the current here. Now my stack top is 1, so top of stack is 1, and my current element is 1, and my k is greater than 0. So means I still have some item that I can remove, right? So I will simply remove this from the stack. I will input 0 because 0 is smaller than 1. Now my k will become 0, and this will move forward. So now I have 2. Since k is 0, so I cannot remove any more numbers, so I will just append the given numbers onto my stack. So my stack will become this after my loop has completed. So now I have 0 2 0 0 since uh, my character at 0th index is 0, so I will not consider this. I'll have to remove it and number will become 200. Let's just take one more example, I guess, and then 10. I think this is fairly clear because the value of k is equal to 2, so we'll have to remove both of these elements, right? So we'll have to think of. So let's just write code for this, and then we will also discuss time and space complexity of the current solution, right? So let's say that my stack is output, so this is my current stack, and then I'll be having a for loop to traverse my string as number. So for I in range length of num. So let me first write the base condition string. So if my k is equal to length of num, so we are given that k is smaller than or equal to the length of the num, so it cannot be greater. So if that is the case, we will simply return 0 from here, because we'll have to int all the characters from the string. And if so, now I'm basically going to the loop. So if I have a stack, so while stack, and at the top of the stack I have my element that is larger than my current element, I will simply remove from the stack, and I will also reduce my k, which is basically how many element I have removed from the stack, right? So, and I do not want to remove any element if my k has become 0, right? Because when I have removed from the stack, I append my current element, because my current element now is smaller than the element I have seen before. So I will append, actually it will be out, because out in my stack. Out of append. So now I append the current element onto the stack, right? So if all of this is completed, and if I still have my k left, so if my k is greater than 0, I will remove, sorry, while k is greater than 0, so I will remove the last elements from the stack, right? And now let's say in this case, if I have my 0 at the start of the string, I'll have to remove this 0. For that, I basically do is while stack and stack 0 equal to 0, I will simply make stack starting from position 1 instead of position 0, right? So now if I still have my stack left, I will convert that stack into a string, while I am writing stack all over the place. Sorry guys, this word stuck in my head. Stack stuck. if out, else we will simply return 0 because that means we have removed all the element from the stack and we have written that. So let's just try to submit this code. So this worked for this for the most part. Let's just try a few more examples. 1 0 and I remove all the elements, which will be 0. Okay, and let's just try that also. I am just removing one element. Cool, so let's submit this. So what is code accepted? Yeah, so not bad. I did not perform that well, which was 34.64%. But anyway, I'm able to solve the problem in an efficient way. So let me just talk about the space and time complexity of the current solution. So we are traversing the given string one time. So this will go by the number of element we have, so it will n times it will repeat, and then this will basically have negligible size, so we can say this will be k, right? So at max we will only have k element in the stack because we are removing those elements from the stack. So I think n into k is the time complexity here, and space complexity will be linear because we are using a stack. So yeah, so the space complexity in this case will be, so time complexity will big O of n into k, and the space complexity of this solution will be big O of n, because I'm using a stack to store the elements. And the worst case will be when all the elements are ascending, all the elements are in descending order, because in that case, let's say I have a string which is like 5 4 3 2 1, so each time I will be getting a smaller string, I'll have to keep removing the element from the stack. So that is my worst case here. So yeah, I hope you understood the logic behind it, and also I have followed up. So for more such videos, please like and subscribe this video, and also hit the bell icon if you want to receive notifications whenever I will upload a new video for the solution. Thank you guys for watching.